Year 13 short revision video number 22. So we have a mechanics question here quite clearly. We've got a block of mass 4m kilograms, so that's the mass of that block, and I'm going to draw in the weight of that block immediately, which is 4mg, and I'm going to draw in the normal reaction force upwards like that, and there's a particle of mass m kilograms, so let's draw on the weight of that particle over there. They're connected by a light, inextensible string passing over a smooth pulley. So we can draw the tension here and the tension here. The block is on a horizontal table and the particle hangs freely. The part of the string between the pulley and the block is horizontal. The block slides towards the pulley, so that gives us a good indication of what's going on here. The block is sliding towards the pulley, so it's accelerating to the right like that, and of course the particle is accelerating down with the same acceleration like that. The particle descends. In this motion, the frictional force between the table and the block is a half mg newtons. So the block is moving to the right, which means friction will be opposing this motion, a half mg. And we have got to find expressions for the acceleration in the system and the tension in the string. So we are going to analyse the two elements of this separately. I'm going to start with the particle. Now, we're going to use Newton's second law of motion, which is that the resultant force equals mass multiplied by acceleration. I always write this as a vector equation because, in theory, we are looking at vector forces here, even though we simplify it by looking at particular directions of motion. So the particle is moving downwards. Let's make down the positive direction. The resultant force is the weight, mg, minus the tension, which is equal to the mass, m, multiplied by the acceleration, a. Let's do the same for the block. The block is moving to the right, so we'll take going to the right as positive. So we have the tension, take away a half mg to give us the resultant force. Those are the only horizontal forces acting. Vertically, of course, the normal reaction and the weight would be balanced. And this is equal to the mass, which is 4m, multiplied by the acceleration, which is, of course, a. So we have our two equations of motion. We've now got to solve these in order to find the acceleration and the tension. Notice it says find expressions for, so it's likely that our answers are going to end up being in terms of m as an unknown. So this is perfectly set up for us to add the two equations together. If I call this equation 1 and this equation 2, equation 1 plus equation 2 is going to give me mg minus a half mg. I'll write that down for the moment and simplify it. On the left-hand side, t and negative t obviously cancel. On the right-hand side, 5ma. Now, on the left-hand side, we get a half mg equals 5ma, and actually, m is going to cancel from both sides of this. So we won't end up with an answer that's in terms of m. We're going to end up with a equals 1/10 of g, or 0.98 meters per second to negative 2, and we can simply substitute into either equation to find out the value of t. I'm going to substitute into equation t, so t minus a half mg is equal to 4m multiplied by a, which I'm going to write as g over 10, so I can give my final answer as a fraction, and it simply simplifies to t equals 9/10 of mg. So t actually does feature m. If you want to, you can work out what that is as a decimal coefficient, and it's 8.82m.